So the first thing we're going to look at is the Greek alphabet, and this is something that you should have seen most of these letters somewhere before. Pi obviously was probably the first Greek letter that you were ever introduced to, but there is a capital and lowercase for each one of these. They will show up, they're universal, so they show up in your upper level math and science classes, and they will, mean the same thing universally, no matter what language you speak, no matter whatever. So one of the reasons we're looking at this today is for theta, because once we get into trig, we're big boys and girls now, and so when we have a missing angle, we don't normally use x. I mean, we can, I'm not going to say you'll never see it again, but theta is kind of your default for a missing angle. And just like if we used x and x was used, then we'd go on to y and z. When theta is used, usually, but not necessarily always, you go then to alpha and beta and the lowercase ones, and those are going to be your angles. So I want you to see what these look like. You need to know what the names of the consistent ones are. I'm not saying you have to memorize all of these. Depending on what math and science classes you take in college, you may have to memorize this. I did have to memorize it. And you'll just kind of learn them as you go. I'm sure you've heard of gamma rays. Delta, the little triangle, right, means, what does delta mean? Huh? Legally bond. Delta, delta, delta. Means change, right? The change in. Does that sound familiar? Y'all are in science, right? Yeah. The triangle. Exactly, the change in y over the change in x. So I'm not going to read all this to you. You can read it, but I wanted you to have this. I am going to show you a little video, because just like the American alphabet, and I'm sure other alphabets that I don't know, has a song, so does this one. So here's your little earworm for today.
Alpha, beta, gamma, rays, delta, epsilon, hey, 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 zeta, eta, theta, iota, then there's kappa and lambda, mu and nu and xi, xi, omicron, and then there's pi, rho and sigma and tau 2, upsilon, it starts with U. Phi and chi and psi are fun. Omega, and then you're done. Learn all that and then you're set. That's the whole Greek alphabet.
Okay, so, and if you look at the paper that I gave you, and look at some of the pronunciations, they might have been different than what was in the video. It's kind of like either and either, tomato, tomato type of thing, depending on who who says it and whatnot. But even here it says psi, but he said psi, and then phi or phi, upsilon and upsilon, but it's a y, not a u. That's why it says it starts with u. So anyway, that is your Greek alphabet. So now let's go and, oh goodness. This is nice. They have a new little thing here, and I don't know how to make this go away. Go away. Okay. Not what I wanted. Oh, this is bad because I can't. Okay. Well, I got to figure out how to get that off. All right. There we go. So we're going to review trig functions from geometry. All right. So in geometry, you learned 3 trig functions or 3 trig ratios. There's actually 6. The other 3 are going to be super duper easy. So first of all, let's talk about what trigonometry means. Trigonometry literally means triangle measure. Okay, it's the study of the relationships among the side and angle measures in triangles. The difference between trig and other triangle relationships that you did is if you had similar triangles, you were comparing the side of one triangle to the corresponding side of another triangle, and that's how you made your ratio. But in trig, you're making your ratio out of 2 sides of the same triangle, okay, and that makes it a little bit different. So a trigonometric ratio, what does the word ratio in math usually refer to? How do you make a ratio? Fraction, exactly. So ratio usually means fraction. You can do ratios different ways, but in math, usually we're making a fraction. Trigonometric ratio compares the lengths of 2 sides with respect to an acute angle theta in a right triangle. As far as you're concerned, when you're in geometry, you can only do trig with right triangles. As far as you're concerned right now, you can only do trig with right triangles. We will get to other triangles, but we're not there yet, okay? And then trigonometric function is a rule defined by trigonometric ratios. So you'll hear me refer to them as functions or as ratios, and kind of go hand in hand. All right, so in order to be able to set up our ratios correctly, we have an acronym. Anybody tell me what that acronym is? SOHCAHTOA, there you go. So that is SOHCAHTOA. You have to spell it right to use it. That's how acronyms work, okay? So you have, if it's a right triangle, you'll always have one right angle. That's what makes it a right triangle. Then the other two angles are both acute angles, and they're complementary. They have to add to give you 90 since that one's 90, right? So in the triangle, you either decide which angle you're focusing on, or it's already decided for you depending on what you're doing. This is already labeled as theta. This is my angle, okay? So from theta, I'm going to draw an arrow across from it. That makes this the opposite side. Across from the right angle is always the hypotenuse. And then the other side is the adjacent side. Okay, it's attached to theta along with the hypotenuse. I ain't reteaching you how to label triangles if you don't know what the hypotenuse is. You're in the wrong class if you can't figure out the hypotenuse. I'm sorry. We don't have time for that. Then when we move on to the functions here and the ratios, you have the actual names, sine, cosine, tangent, cosecant, secant, cotangent, and then the abbreviations. Sine, cosine, tangent. It is not sin, cos, and tan. Because what would this be? Cosec and sec and cot? That makes no sense. Plus, let's say that you went to the doctor, right? Your doctor's name is Dr. Smith. Would you walk in and say, well, hello, Dur Smith? Yeah, no, because you sound like a moron. When you say sin, cos, and tan, you sound like a moron. Like you don't know what you're talking about. Make sense? They are abbreviations. You don't pronounce them out. Don't get that wrong. Okay, so what this little acronym tells us, this SOH, that is sine, is opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. That is 100% review, something you're expected to already know. So these other three, cosecant, secant, and cotangent, the names of them, hopefully you learned about secant lines at least. We'll talk about how all that is related later on. We're not ready for that either. But these are just reciprocals of the first three. So if you know the first three, you can do the second three, no big deal. And here's one thing I want you to focus on and understand now. Notice in these three, the first three, there's one that has a co in the name. In the second three, there's two that have co's in the name. So there's 3 co's and 3 that are not. Each pair that are reciprocals, there's only 1 co in each pair. That'll help you keep them straight, okay? So sine and cosine aren't paired together for reciprocals, even though you might think it makes sense. Tangent and cotangent are, though. So cotangent is just the reciprocal of tangent. That means it is the adjacent over opposite, right? Then sine goes with cosecant, cosine goes with secant. Only one co in each pair. So that makes this one hypotenuse over adjacent, hypotenuse over opposite. Hypotenuse over opposite. And hypotenuse over adjacent. Now, how you remember them, totally up to you. The way I remember them, and I've known these forever, is if you ask me what cosecant is, my brain is going to go, cosecant goes with sine. Sine's opposite over hypotenuse, so it's hypotenuse over opposite. Make sense? Like I know these through these, because I know these very well. So, how you either know it that way, or you just know these other three, whatever works for you. All of our brains work differently. Okay, we good? Easy enough? All right. So these are reciprocal functions, right? And we literally just took the reciprocal of this to get this. And so it says because cosecant, secant, and cotangent ratios are reciprocals of sine, cosine, and tangent, they are called reciprocal functions. So yes, it is hypotenuse over adjacent, but cosecant is the reciprocal of sine, so this is also 1 over sine theta. Secant is the reciprocal of cosine, so it's 1 over cosine theta. And cotangent would be 1 over tangent theta. So there's two different ways to look at them depending on what we're doing with it. Okay. We good? But if I want the cosecant, there's no reason for me to take 1 over opposite over hypotenuse, right? I can just literally take the reciprocal, or I take 1 over the value, whatever it is. All right, so let's look at how we're going to find the exact values here. We're not solving for anything. We're just finding ratios, right? So we're talking about theta. So they've already decided what my angle is for me. Here's theta. So across here, this is my opposite. Across from the right angle is the hypotenuse. This is adjacent. So I just have to set them up and clean them up. Sine, I know, is opposite over hypotenuse, so it's 4 over 4 square roots of 5. Can I reduce that? Can I cancel the 4's out? Maybe. What if it was, if you're not sure what to do with square roots, think about them as variables. 4 over 4x, can you cancel the 4's out? Yeah, you totally can. What would this leave me with? 1 over the square root of 5. Can I leave it like that? No, I have to rationalize the denominator, and when I do, what do I get? Square root of 5 over 5. Yep. Okay. Good with that? Then cosine of theta is adjacent over hypotenuse, so this is 8 over 4 square roots of 5. Can I reduce that? Yes. That becomes 2 over the square root of 5. And then when I rationalize, what does that become? 2 square roots of 5 over 5. Then tangent is opposite over adjacent, so that's 4 over 8, which is 1/2. So the second set, since I already have the first set, I can just do the reciprocals. I don't have to actually go calculate them. But all three of these fractions here have the same value. This is just the form I need it in. So when I take the reciprocal of it, I can choose any one of these three that I want. I'm thinking I want this one. Would you agree with that? Because what's the reciprocal of 1 over the square root of 5? Square root of 5. I mean, I could take the reciprocal of this and then rationalize, but that's just a whole lot of work I don't need to do. So what's the secant of theta then? Square root of 5 over 2. And then cotangent would be 2. Okay. We all good with that? Any questions? All right. So let's look at number 2. Here is theta. This is the opposite side. This is the hypotenuse. This is the adjacent. I have a little bit of a problem here. What's my problem? I don't have the hypotenuse, so I need to find it. How can I do that? Pythagorean Theorem. Welcome to 6th grade. All right, so that would be 6 squared to 3 squared, but it has to look like that. And then plus 6 squared equals h squared. How do I square 6 squared to 3? 36 times 3. This would be 36 times 3 plus 36 equals h squared. What's 36 times 3? 108 plus 36 equals h squared. So h squared equals 144. What does h equal? 12. Should it be plus or minus? What do you think? It's always positive because it's a side length, right? Negative wouldn't make any sense right here. All right, so now that you have that, you go ahead and fill in sine, cosine, and tangent. All right, do y'all agree with those three? Yes, we're good. All right, so when I go to find the cosecant, if all I needed was the cosecant and I didn't already have the sine, then I would want to go do hypotenuse over opposite. But I can just take the square, not the square, the reciprocal of one of these. I think I'm going to take this one. So this would give me 2 over the square root of 3. What does that become? Yep, 2 square root of 3 over 3. Then what would the secant of theta be? 2. Reciprocal of the square root of 3 is 1 over the square root of 3, which becomes what? Square root of 3 over 3. That happens every single time. The reciprocal of the square root of 5 is the square root of 5 over 5. The reciprocal of the square root of a monkey is the square root of a monkey over a monkey. Doesn't matter what it is, okay? We good? Questions? All right. So this next set of instructions says use the given trigonometric value to find the remaining function value. So they gave me the tangent of theta. And I need to use that to find the rest of these. So already I know that tangent theta, my answer is 7 over 24. What's the cotangent of theta? 24 over 7, right? So that was pretty easy, but I need the other ones. I don't have a picture, so I'm going to draw one. A right triangle. Then I'm going to put a theta somewhere. Doesn't really matter where, as long as everything's labeled correctly after that. So then that makes this the opposite side, this the hypotenuse, this the adjacent. Tangent, I know, is opposite over adjacent. So I can label the opposite 7 and the adjacent 24. That doesn't mean that that's for sure the side lengths, because those could be reduced ratios. Maybe it was, but at least that's the ratio of them. Then I need to find the hypotenuse. How do I do that? Pythagorean theorem. So I get 7 squared plus 24 squared equals h squared. So that's 49 plus 576. You should know your perfect squares to 25 so that that doesn't become an issue. Otherwise, you're going to spend the whole time doing basic multiplication, which is a complete waste of your time. What's this? What's the square root of 625? 25. Yep. All right, fill in the rest of those ratios. These will be easy because nothing reduces. Do we agree with all that? We good? Awesome. All right, so now we have secant of theta, which is 4. So this is 4. Then what's the cosine? 1/4, because it's the reciprocal. I'm going to draw my triangle, make a theta, opposite, hypotenuse, adjacent. So then secant is a whole number, so I'm going to put it over 1, so I actually have a fraction. Secant is a reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent, which means I can label the hypotenuse as 4 and the adjacent as 1. You find the opposite. And it's not the square root of 17, by the way. Square root of 15. Make sure you do Pythagorean theorem correctly. Then you go ahead and fill in the other 4 missing ones. what questions do you have? Anything? Good. All right. So let's talk about trig values of special angles. So you also in geometry learned special right triangles. Okay, and they had you had a 30, 60, 90 and a 45, 45, 90. And they had a special relationship so you could find missing sides. So when you did this, how this was labeled for you to solve could have been used with x's. I personally think that's a very bad idea, and I would never teach it that way, but that doesn't mean that you haven't seen it that way. Instead, and it's because when you go into solve, it can get all confusing with the x's. Instead, for 30, 60, 90, you have a hypotenuse, a short leg, and a long leg. Short leg is always across from 30, and everything is based on the side length of the short leg. So we're going to use s instead of x. So across from 30 is the short leg, so that's an s. It's not a 5. Make sure you can read my handwriting and your handwriting. Then in a 30, 60, 90 triangle, the hypotenuse is always 2 times s. So it's twice as much as whatever the short leg is. And then across from 60, which is the long leg, is always s square root of 3. Okay. In a 45, come in, 45, 45, 90 triangle, this is an isosceles right triangle, right? And the two legs are the same length, so there's not a short leg and a long leg, so we're going to use L. So this would be L squared of 2. Okay. That should look familiar even if you had x's there instead of l's and s's, all right? And the variables are there for you to be able to set up little equations to solve things, all right? But we are going to look at what if the length of the short leg is 1, so we can get ratios out of this. The length of the short leg is 1, then that makes the hypotenuse 2, and that makes the long leg square root of 3. In the 45, 45, 90 triangle, if the leg length is 1, then this one is 1, and the hypotenuse is the square root of 2. Does that make sense? Just so we have actual lengths to use to find our ratios. Now, eventually, we're going to get to the point where these values, you have to just know them. What's the sine of 30, the cosine of 30? And you will know them. I will get you there. I'm not saying go home and memorize these tonight because I have a process to take you through. And if you actually do it and don't resist me, you will know them with no problem, okay? Because there's patterns all over the place. Right now, you're expected to be able to find them. And then, like I said, we'll get there. So knowing what we know, we can go in here and say, all right, so the sine of theta, in this case it's 30. I'm not going to label my triangle with opposite and adjacent because I'm also going to do 60 and then the opposite and adjacent changes, right? So the sine of 30, here's 30. Sine is opposite over hypotenuse, so that's 1 over 2. Cosine, here's my 30. It's adjacent over hypotenuse, so that's the square root of 3 over 2. Tangent is opposite over adjacent, so that's 1 over the square root of 3, but I can't leave it like that. What does it become? Square root of 3 over 3. So that's really what the value is, right? What is the cosecant the reciprocal of? Cosecant goes with sine, so this is just 2. Secant goes with cosine. Remember, there's only one co in each pair. So this becomes 2 over the square root of 3, which is actually 2 square roots of 3 over 3. And then what would the cotangent be? Square root of 3. Okay. Everybody good so far? No? Questions? All right, so let's do 60 before we do 45 because we're in the same triangle. The sine of 60, that would be opposite over hypotenuse. That is the square root of 3 over 2. Cosine is adjacent over hypotenuse. That's 1 over 2. Look at your little chart and tell me what you notice at this point. There's switch. The sine and cosine here are just in opposite places here, right? Every single time in a right triangle, I don't care if it's 30, 60, 90 or not, these two angles have to be complementary, right? And the sine of one angle is the cosine of its complement. So if I had, even if this was 32 and 58, these two things would have just switched places, okay? Make sense? So when I say you have to know these values, notice these aren't new values, right? They're just opposite, and so there's not a whole lot of new numbers in here. You just have to understand how the patterns work. All right, so then tangent of theta of 60, it's going to be the square root of 3 over 1, so that's just the square root of 3. So what's the cosecant going to be then? You just give me the final answer. If sine and cosine switch places, doesn't it make sense that these two have to as well? So this is just 2 square root of 3 over 3. Secant is 2. Cotangent's the reciprocal of the square root of 3. What's that? Square root of 3 over 3. Everybody good so far? Understand how to find all that? All right, so then we're going to look at 45. So I'm going to use this angle here. Sine is opposite over hypotenuse, so that's 1 over the square root of 2, which becomes the square root of 2 over 2. Cosine, 1 over the square root of 2, right? Which is square root of 2 over 2. Does it make sense that those are the same? Yeah, because the two angles are the same, right? What's the tangent? 1. Cosecant is the reciprocal of sine. What does that make it? Square root of 2. Secant would be what? Square root of 2. What's the cotangent? 1. So when you look at this, there's not a whole lot of different, there's a lot of numbers there, but they're the same over and over again. And again, as long as you recognize the patterns, you're going to be good. All right? What questions you got? Anything? Awesome.